Good afternoon, everyone. Welcome to another RISSB webinar. My name is Sudha. I'm part of the senior leadership team at RISSB, overseeing the products and data system. I'm the GM of Products and Innovation, and I'll be your host for today. Before we proceed any further, I'd like to acknowledge the traditional custodians of the land where we meet today. And for me, it's in Perth today, and that's the Whadjuk Noongar people. I would like to pay my respect to their elders, past and present, and extend the respect to Aboriginal and Torres Strait Islander people with us today. Today's topic is called Wayside Electrical Charging Infrastructure Interfaces for Battery Electric Rolling Stock. And the presenters are my colleagues that I've known for a few years and worked with. Firstly, let me introduce Cris Fitzhardinge, the Senior Standards Development Manager at RISSB. Cris has over 25 years experience in the railway industry in both operational and technical roles. He has worked for both public and private sector and has been involved in providing safety, harmonising, interoperability solution for the Australian Railway, working through at RISSB, ARTC, Rio Tinto, and other various organisations. Cris holds a business management degree from the University of South Australia and a diploma in transport safety investigation from the Australian Transport Safety Bureau, ATSB. He currently resides in Baldivis in Perth with his wife and children. Outside his work, his passion is Railway Preservation Society. Loves everything about the rolling stock and everything about the railway. And look, as some of you may or may not know, he participated at the hard quiz, ABC hard quiz on rolling stock information, and he won it. So, big tick for him. And he's a real rail buff. And if you want to have conversation about that, he's the right person to reach out to. Also presenting today is Bruce Wooldridge, Standards Development Manager with RISSB. Bruce is a qualified mechanical engineer for over 37 years experience in the railway industry, encompassing rolling stock design, maintenance, project management, rail operations, engineering management, technical advisory, strategic sourcing, and business development. During his working career, he's been engaged across a wide range of rail organizations, including freight and passenger operations, government agencies, consultancies, vehicle designers, manufacturers, maintainers, component suppliers. Bruce has extensive experience, deemed a subject matter expert in all aspects of rolling stock. And I think internally, we often reach out to him if you want to have a conversation around that. In addition, he's also a member of the New South Wales chapter of RTSA. And he's also a volunteer Marine Rescue New South Wales, volunteer at Marine Rescue New South Wales, and quite often on the weekends he's on the border. So welcome to you, Bruce and Cris. Thank you for taking this time to take us through this information on the recently released standard. Just a quick reminder for everyone who's participating, the Teams chat are available for any questions during the presentation. Please note them down. As always, be respectful with any other comments that you add in the chat. Without any further ado, over to you, Cris and Bruce.
Great, thank you very much, Sudha, and thank you very much for the opportunity to talk to everyone today around the standardisation of rolling stock charging interfaces. I'll just bring up the slides for everybody. So recently, RISSB developed AS 7655, and this is what we're here to talk about today. But just to kick off the proceedings, I'd just like to talk to you a little bit about RISSB's strategic focus. So it's really important within RISSB that we're building capacity and systems to support informed decision-making by industry and government. So this is what we're really working towards here at RISSB. We're working obviously closely with governments on interoperability and harmonisation, but also with a future-facing focus, which includes sustainability in the rail industry. So we are very mindful of net zero, changes in systems that promote net zero, make our railway systems more sustainable. It's a really important part that we need to play. Obviously, our annual work plan really focuses on industry's most pressing issues. And we've got that real increased focus on product adoption and benefit realisation. So it's not that RISSB just wants to pump out products. We want to put out products that are really valuable to the rail industry, that the industry wants to adopt, take up, and then get some genuine benefit for. And that is a real focus for us as we move forward. So the RISSB products, I mean, they're developed by industry for industry. It's not a case of RISSB sits around and talks and says, hey, let's write a new standard. We'll sit around at a coffee table, put together a standard, then kick it out the door. It's not how it works. We work with industry. Industry is the driver for everything we do. We do it for industry. We work with industry to make sure that we get the best benefits for industry. That's what we're about. We do use our combined knowledges and experience in-house, and we also bring in external SMEs. We've got a fantastic group of people here at RISSB. We worked out recently that within the SDM team, we have over 300 years experience in the rail industry, which is quite exceptional for such a small organisation. But we also look to local, national, international learnings. We look at safety investigations. So we look at what's coming out from the ATSB, what's coming out from ONSA, what major incidents have happened overseas. What do we need to learn from to make our products more valuable and more beneficial to the industry? So we do a lot of work to make sure that we are developing the best possible products for the Australian industry. So net zero. So this is what we're starting to get into. So net zero is changing the way that we do things. Now, rail transport, okay, it's only about 4% of Australia's total CO2 emissions. But if we're going to get to net zero, we have to play our part as an industry. So that 4% needs to come down. So the federal government is obviously driving that net zero emissions by 2050. And now is the perfect time for us to really be looking at these sort of things. So Australia's large locomotive fleet, there is a lot of locomotives that are coming to the end of their life. So if we are looking to replace a lot of those locomotives, now is the time to start looking at how can we make those locomotives more carbon efficient than the ones that have gone past. Those people from New South Wales will no doubt recognise the good old Alco 44 class doing its usual thing of spewing a whole heap of exhaust fumes into the air. That's just not acceptable these days. So what can we do to try and reduce the impact? So why standardise? What's the great thing about standardisation? I'll take you on a short little journey across to the issues around mobile phones. Now, anyone who has been around for 20 or 30 years will remember the days when every single phone, even within the same manufacturer, had a different charger. So we had all these different chargers. You go around to a friend's place and you say, oh, my phone's nearly dead, can I charge it up? And unless they had exactly the same phone as you had no chance. Your phone was going to die. So it was ridiculous. On top of that, every time you bought a new phone, you had to go and get a new charger. It came with a new charger. So what did you do with the old charger? Well, you generally threw it out because it wasn't good for anything. So a study in Europe found recently that over 11,000 tonnes of electric waste is created by discarded phone chargers, which is quite an amazing amount. So why standardise? Here's a pretty good reason why. 11,000 tonnes of electronic waste every year. So what did Europe do? They've decided to standardise. Electric car chargers. Already we're starting to see issues there. So whilst Australia has adopted a standard CCS2 type, it's not a requirement. So some cars use different chargers. Now, if you think of your current cars today, if you're using a non-electric vehicle, so you've got a diesel vehicle or a petrol vehicle, at least when you go to a service station, the nozzles are all the same. All right, you can pull up to an Ampol, a Caltex, a BP, it doesn't matter. You can fuel up your car. However, if you had an electric car and Caltex, let's say, only had one type of charger and BP had the other type of charger, then going to the wrong service station isn't going to help you a lot. You're not going to be able to charge your car up. Put that into context of a locomotive. If we start seeing more and more battery locomotives around Australia, and as they are being developed, and we're running around the network, and we need to charge our locomotives, does it make sense that we will have to have different depots for different locomotives to charge? I think you all know the answer to that. Pretty simply, no. That's inefficient. That drives high investment costs. It would just be ridiculous. So Europe has made a big move on chargers already. So they have now standardised on the USB-C charger for electronics. The idea here, of course, is that now every device will be charged by the one type of charger. That should dramatically reduce the amount of waste that's going to refuge sites, like that 11,000 tonnes, because you'll be, no matter whether you have a laptop, a phone, a tablet, they all charge using exactly the same device. So you'll need one charger for all your devices. Now, this has come in on 28th of December, a couple of years ago. Laptops will come in more recently, and now they're looking at standardising car chargers for the same reason. So why don't we should be doing this for our locomotive fleet. So at this point, I'd like to welcome Bruce to the stage, and he can talk to you about what we're doing in the way of standardising locomotive chargers. Thanks, Bruce.
Thank you, Cris. Cris, can you hear me? Just making sure my mic's working. Yep, great. Yep. Okay, thank you very much. Yeah, so as Suda spoke earlier, I suppose I've been playing trains I think it's actually coming up to 40 years next February, which doesn't seem that long ago in my lifetime. It doesn't feel that long ago, but I've done a lot, I suppose. So with this standard, and just highlighting or just modifying a little bit what Cris was saying about, it's not just locomotives we're looking at, it's any types of rolling stock. So most of you are aware of the autonomous electric container wagon that they're trialling over in WA that ARC Infrastructure are doing. There's also coming online more types of infrastructure maintenance machines, which will be potentially electric. And then of course moving into passenger and also and light rail. So there's a bit out there. I suppose the main focus, yes, was locomotives, because that's where a lot of the need is, but we didn't limit ourselves in this standard. So why did we do it? We had quite a few discussions with Roger Buckley from Horizon, who's one of the key people working in the decarbonisation space, and there are other operators around the country as well who saw this need. So we know that RSO's operators are moving to these low emissions. At this stage, I suppose it's more in a trial phase and development phase, because the technology is still fairly new. It's got a long way to go till it's probably optimized. And as battery technologies improve, of course, things will improve. You'll get, lower mass, lower volume for a high capacity of battery. But for the charging infrastructure, nothing's sort of really been defined in this space. And what we're trying to do was avoid all the suppliers of the various types of rolling stock or battery electric rolling stock to have their own sort of bespoke charging system. So we're trying to identify some different ways where we could make it a little bit more like open access, like as Cris talked about, you go up to fuel your car with diesel or petrol, and depending which nozzle size, well, shouldn't put diesel in a petrol car, of course, and vice versa. But it's as simple as that, and trying to come up with some ideas and some requirements around those interfaces. We didn't really worry about what's on the train itself, and we didn't also really consider the charging infrastructure needed, although we have made some references and some requirements around that in some regards. Of course, if you're going to have a whole heap of electric, say, locomotives or high energy type rolling stock, you can't plug them all in at the same time unless you've got the appropriate electrical infrastructure to provide that power. So that's sort of a separate thing outside of this. So let's move to the next slide, please, Cris. So as usual, when RISSB is going to develop a new standard or update a standard or one of our codes of practices or guidelines, we engage a development group. So we call for the development group members, of which there you can see the companies that we had development group members from. So it was right across the length and breadth of the country, which was fantastic. Wabtec were also part of that as one of the main suppliers of the equipment, which was great as well. And we also engaged Jacobs to help us with the authoring. So Jacobs, just acknowledge them and the work that they did in assisting with the authoring of this standard and working with the development group. So we looked at 5 different options. We kicked around what was going to be in, what was going to be out. We decided that inductive type charging is probably really not practical and probably not going to be used, so we kept that out. But we came up with 5 options, and as I remember discussing this with Roger Buckley early in the piece, and we're developing the scope, it's fully understood that this is not the optimal solution or optimal solutions for charging. It's a set of requirements of where we think we're at now, based upon what we know. As this technology evolves, this standard will evolve. We'll need to evolve as well to meet the learnings, I suppose, as we go through these sort of trial phases of learning how this technology works and how we can make it better. So it's a stepping stone to try and fill a gap in the market and provide some guidance to industry. Thank you, Cris. So you'll see in the photograph there, that's the ARC Infrastructure Autonomous Container Wagon, which is a battery electric vehicle as well. So we looked at 5 different options. Those options were started off as like your Tesla or whatever, or maybe that's the bad thing to say these days, electric type of road vehicle, a plug-in type. In high and low power charging options. We looked at a type of roof-mounted conductor charging, like with a reverse pantograph that would come down from a roof structure onto a conductor on top of the rolling stock. Charging via, the other option was charging via traditional overhead. I know some operators are looking at, are there ways of not having to string their overhead wire up for the whole length of their corridor, but if they can do sections, they can operate the train from that power under overhead, but also be charging their batteries up during that phase. So we looked at that in both AC and DC, and even considered third rail. Battery tender vehicles was another one. That's basically like and I think Horizon are having a look at this at the moment, basically having like a big container or type of container with batteries behind the actual, say, locomotive or battery electric rolling stock to provide additional power. That would come through via cables, of course. And the last option we just looked at was basically your emergency charging, your mobile charging. If you get stuck and you run out of juice, I suppose, and you've got no other way of moving the vehicle, just like a portable, maybe trailer mounted type system to get there. Cris? So looking at the option 1, now this diagram is out of the standard, so please be great if everyone who's got availability to get the standard to have a look through it. So we looked at standardising across the CCS2, which is what Cris talked about for cars. It's more for low power. But there's also the MCS megawatt charging system as well, which is a designed for larger current flows. There's a group of there's an organisation called Charing, which is a global organisation, has about 300 members, and they look at standardising charging systems mainly for road electric vehicles, but they're also looking at things like mining electric vehicles. We know that I think it's Fortescue FMG have got some electric, battery electric haul pack trucks up on site, and that may be something that some of the big miners will be going towards. So trying to standardise the type of plug-in system that the locomotive or the electric rolling stock may have with, say, mining trucks, sort of makes sense, right? So especially if you're looking at, say, the big operations in the Pilbara or the Hunter Valley Coal or Queensland Coal, where you can share that type of charging infrastructure potentially. Okay, so in this case, the charging has an off-board supply and then an on-board supply, as you can see in the diagram. And it's as simple as plug it in and charge it up. Of course, the charging, I suppose, parameters needed, how fast you can charge, how much energy capacity you've got, how much current you've got to pump through, is going to be dependent upon your operation. You set it up. So the smaller the charger, the smaller the capacity of the plugs, the longer it's going to take to charge the batteries up. But that's fairly obvious to most people. Cris, next please. So option 2, you can see there on that pole, it looks like we've got a pantograph. So the idea is that the train or piece of rolling stock would come underneath a structure, and the pantograph on the structure then would lower when the train's in the right position and engage with conductors on the top of the, I'll just say locomotive, but it could be any type of battery electric rolling stock. That could be a single, it could be a multiple. There's no reason why you couldn't have more than one if you wanted to have more. And that charging interface would work similar to the plug-in, but a little bit less, I suppose, cabling having to have around, and you might be able to get more current through there depending upon how that connection is between the reverse pantograph and the rolling stock. Cris, next one, please. So charge on the run or static charging via a standard pantograph, standard type of overhead is certainly something that's, as I talked about before, that's the industry is seriously considering. Third rail we also looked at as well, unsure whether that would actually happen. There are some safety concerns about running third rail, although you can sort of put isolators over the top, but it's probably less likely, but not necessarily excluded. One of the things here, but you need to consider, is both the overhead equipment and the pantograph and the pantograph conducting strips, how much power you can actually pump through that interface at any one time to charge the batteries. So that would depend upon the type of equipment and the charging strategy, but there might need to be some sort of customized arrangement for how to manage the thermal and heat dissipation at that interface. We of course don't want to have too much sparking and or risk welding the contact head to the overhead wire. So we have written in the standard some requirements and considerations around those potential types of issues that could happen with that. Next, thank you, Cris. Battery tender vehicles. So I explained before, we've got as you can see there in the image, it's like having almost like a say a 40-foot container wagon, something like that, or two 20-foot container wagons behind the piece of rolling stock, and that's connected through electrically via cables. Charging of those could be via any of the methods. It could be via reverse pantograph, could be via normal pantograph, or it could be via plug-in. So just be dependent upon what the particular operation required. And they could be strung together as well. There could be multiple packs of battery tender vehicles behind the locomotives, but understanding that the more you have, the less payload you're going to be hauling. If you're hauling heavy haul, coal line or whatever, and you're maximising your train links to your infrastructure, you're going to start dropping off wagons, I suppose. So that's a consideration there, but you've got to weigh that up against the net zero benefits. Next slide, please, Cris. So yep, that's right. This slide. So in 7655, we have also defined requirements or considerations around various areas that we thought were important to highlight. As we go over time and we learn more about these technologies, these will probably increase. But things, as you can see there, general safety and design, fire safety, of course. We all know the stories around probably not as much in terms of battery electric road vehicles, because I think there's probably less fires than are actually made out to be in the media in terms of the percentage of vehicles out there. But other types of battery technologies causing issues when they're on charge. So that's an important thing. And also around the charging infrastructure, you might want to have it out of the way of the rest of your main locomotive shed, for example. So if something does happen, you're not going to take out a whole facility. And there are other ways of controlling that electrically as well. The operating environments, definitely, we're talking about anywhere in Australia from 0 degrees to the Pilbara, which is 50 degrees, getting close to or more these days. High humidity environments as well, very dusty environments. So it needs to survive under those environments. Environmental impact and sustainability. I mean, this is the reason why we're doing this. Looking at things like the whole supply chain of how this is going to be instigated, the types of technologies, like the cradle to grave, and also considering things like how you dispose or recycle of the equipment when it's asset expired. If anyone remembers the old NiCad batteries, you really can't do anything with them. The cadmium's very noxious, and any way to really get rid of them was to bury them. So we're trying to not create new environmental problems by trying to solve our carbon emission problems, I suppose. Our RAMs, reliability, availability, maintainability, and safety, goes without saying. We need to have targets there for the reliability to make sure that the systems will work when we need them to work. Cyber security, look, it is important. Everything's linked these days. Everything's connected, our systems. I don't know if everyone's seen the news this morning, but apparently Spain and Portugal have had a massive power outage. I haven't read the news in the last few hours, but I got no idea what that is. So to wipe out basically 2 countries worth of power is a big deal. I don't know whether it was a cyber security issue or something else. But in terms of just, charging these trains, we need to make sure things can't be hacked so it ends up in an unsafe situation. Things around the actual power itself, harmonics, the power factors and voltage fluctuations, we've considered in there and put in some requirements. Electromagnetic compatibility, earthing, of course, as well for safety. Communication and control. So this is basically the handshake. When you connect the charging infrastructure to the vehicle, it needs to basically handshake. Yes, I acknowledge that you're there. I can see that you're there. I'm ready to charge. Everything's safe. The charging infrastructure is ready to go, and it's basically that check. And also during the phase, if a fault is noted in the system, then it will potentially disconnect that charging to take it back into a safe mode to ensure that hopefully we don't have issues with electrical issues or fires. Material handling or manual handling, human factors, of course, very important with the charging plugs. We have made some references in there about heights and weights and so forth. And also emergency stops and alarms, depending on the type of systems where we have those stops and alarms, how far away they are, just in case the automated systems don't detect a particular fault and shut it down, that someone has to hit the big red button. Cris, there's a couple more slides. Yeah, and our last option here is what happens if you run out of juice, basically. So we've written up a small section about the types of chargers that could be used. It could be in a maintenance facility. It could have to go out beside track. Could be some type of power bank module, or it could be a generator set, just enough to get enough energy transferred into the batteries so the vehicle can either get home or at least be moved off a main line so it's not disrupting other traffic. What else do we have, Cris? Yeah, so the benefits, I think this is our last main slide. We're trying to, as I said earlier, we're trying to stop bespoke solutions from suppliers providing their own charging infrastructure, that we don't fall down the path of, I know the mobile phones are sort of a different type of arrangement, and it's very small compared to these, but you just think about those problems we've had, and we want to have like almost plug and play, or however the interface works, standardise across different suppliers, because we want more and more suppliers out there trying to innovate and engineer and come up with solutions. But if we can have sort of almost like open architecture interfaces, then that means it's not, an operator can try various suppliers' equipments on their networks and use the same charging infrastructure interfaces. So it was trying to minimize, I suppose, those costs and those complexities, but also this standard sort of fills a void because nothing has been written in this space. It's primarily, I suppose, the US are looking in this space from the US manufacturers, because the US is predominantly a diesel railways. Europe are playing around with it a little bit as well, but a lot of European railways, everyone knows, are electric, have overhead. So it's a bit of a mix, but there was no sort of standard we could find in this space that really talked about rolling stock. So we put this together to fill a void. And as I said, this is not, there may be some parts of this standard already, might be almost not superseded, but some new technologies or some new ideas have come along. But we'll be looking at this standard fairly regularly. And if anyone in the industry has any comments or knows of some other information or other ways, things we could put into the next revision, please get onto the RISSB website. There is a change register button you can click on every standard, and you can apply that information in there, and that all goes into a database that we review regularly. And in terms of working out when we need to do the next review of the standard, and also it helps guide us in what sort of changes are required. Cris, is there another slide, or is that our end? That is our end. So on that, Thank you very much, everyone. I shall pass back to Suda, who I think is going to coordinate any questions. Thank you, Suda.
Thanks, Bruce. Let me maybe start off with a couple of questions as we wait for a few more questions to come through, just to sort of keep the discussion. Bruce, in the process of the development, what do you think are some of the biggest challenges that rail operators might face when adopting the standard to start off with?
I suppose because it's new technology, it's greenfield. So hopefully there aren't too many challenges in that. But one of the bigger challenges that the operators have got to work out what type of technology they want, what works for them. You need to run simulations, power modeling, to determine what's going to give the best bang for buck. And the other thing as well, commercializing it. We have very good railway systems at the moment that have been set up around diesel trains. Going to battery electric or a hybrid or somewhere in between, or using other types of energy or clean energy, is a massive challenge to make it commercially viable. You know, the BHPs, the Rio Tintos, the Horizons, the PNs, all these big organisations are still publicly listed companies that are expected to make a profit for their shareholders. So it's going to be a challenge, I think, in that to commercialize these types of systems, and we'll see how it develops over the years. You know, maybe battery electric is not going to be the best solution for a lot of heavy haul. Maybe it's going to be a combination of electric locomotives and recharging. You know, it could be, you know, or it could be purely electric type locomotives using clean energy feeding it. But there's massive costs in that, as we realise. So, yeah. But I think setting up the infrastructure or the interfaces themselves, especially if it's a charging point that's going to be static, having enough power on site to do that, and where they're getting that power from. You know, if you're not using green energy, I suppose, to charge the batteries, you know, is there really a point in doing it? So you know, we need to be thinking about where our energy is coming from. So I think a few years ago they were playing around with some hydrogen trains in Europe, and the hydrogen was being manufactured in the next country from coal-fired or gas-fired power stations. So, like, yeah, you can't create energy. Unfortunately, there's always losses. And we need to be thinking about how we get that energy and keeping it as clean as green as possible.
I guess the question again, along with that, Bruce, is it's not just only new technologies coming up, but also there'll be hybrid systems coming as well in the future. And does the standard sort of has mechanisms currently to sort of cater for that, or it'll be a review and an update in the future?
Not really for hybrids. I mean, I suppose if it's like a plug-in hybrid, if you talk about the automotive style that's out there at the moment, then it would suit that. But where we're going with this and hybrid technology in rail, I suppose, is not really the main intent of this one. It's more purely battery electric as a start. But as I said earlier, as this technology evolves, we learn more. There's a lot of work being done. There's some fantastic universities around the world who are working in this space as well. And I dare say the very, very smart people who are mainly electrical, I'm a simple mechanical man, will work out better ways of producing products that can operate in a low emissions way or a zero emissions way to the benefit of the planet. Yeah, so.
Fantastic. Thanks, Bruce. A simple practical question with regards to, you know, when we implement this charging infrastructure, I think the simple question was, can we just use it in workshop power sockets in metro depots? Is it applicable for workshop power sockets in metro depots as is? Or do they need to change some infrastructure in that environment as well before implementing such a system?
I dare say it depends upon how big the battery is, and the power requirement and how quick you need to charge. As you know, if you got an electric car, you can plug it in at home. It just takes a long time to charge, right? Because you're only going through small wires. You can only pump so much current through. So it would really just depend. I mean, in the locomotive space, I would expect that they would need higher levels of power availability to charge it in a reasonable time frame. You don't want to sort of be sitting there for days and days waiting for the thing to charge up. You probably want it done in hours or half a day. I don't know how long exactly it would take to charge. But yeah, I think that would depend upon the size of it and how long you have to charge the unit.
So here's another question for you. In relation to maintenance and inspection of the charging components, what requirements are to be in place to manage the safe use of cables, plugs, etc.? What regular testing and inspection requirements are on an ongoing basis for the infrastructure itself? And has the standard considered that?
Look, not into that amount of detail, I suppose. In terms of safety and maintenance, a lot of the operators have their own systems in place, and there's a lot of other standards that would cover that. So we've sort of haven't delved into that at this point, but I think we have acknowledged, especially with the plug-in type where you do have a cable, yeah, you do need to, protect the cable, keep it off the ground, stop someone running over it with the train, for example, or things like that. But yeah, we haven't gone into that in super detail here because those types of standards I think are already out there, and we leave that up to the individual operator to determine their own safe maintenance requirements in that space.
Cris, probably a follow-on question for you. Do you foresee further sub parts or additional standards that are coming out of this for future? And what is your thought at this particular point in time?
Absolutely. I think that as the technology evolves, there's going to be a need for standards, technical and performance-based standards to assist the industry, to assist OEMs and suppliers and procurers of this equipment to be able to go, right, what are the requirements that we need to meet to provide safe, efficient use of these technologies. It's difficult at the moment because a lot of these are being developed as we go. A lot of them are relatively new and still very much in a development and research phase. But as that information comes to hand and we can understand better the direction that the industry's headed, then absolutely we want to be able to produce those standards to support that. The difficult thing, it's almost like the chicken and the egg. We can't write about something that we don't fully understand, but on the flip side, we don't want to let the industry make up its own mind, and then we end up with a whole heap of interoperability and harmonisation issues. So it's a challenge to try and keep ahead of the curve when the curve is constantly moving.
Thanks, Cris. Okay, this is a slightly different question, Bruce. What arrangements are required to ensure the charging and operation of battery electric locomotive systems are failed to safe mode in the event of a system right side or wrong side failure? This may be slightly outside the scope of the conversation, but yeah.
Yeah, I'm just having a look at that question now in terms of what we've got in the standard. Forgive me, I'm not an electrical expert on this, but there are sections in the standard which do talk about, failing to a safe mode. So that's going to be in, for example, the handshaking mechanism with software. You would probably need to have SIL-rated software for some of those requirements, and other things like earth protection as well. So I'm not, I don't want to pretend to be an electrical expert in this space, but there are some requirements built into that, but they're still reasonably high level at this point in time. because it is the emerging technology. So it would certainly be one of the items we'd look at progressing in the future of providing that level of safety. But of course, ultimately, we're dealing with high amounts of electrical energy. I'm only a simple mechanical engineer, but I know it hurts, right? It goes bang, it will kill you, even very small amounts. So the safety of the system is critical. Testing and commissioning is going to be critical. And then, of course, the maintenance. But we tried to build in as much requirements around self-protection and I suppose knowing monitoring of the system, I suppose, both on board the rolling stock and in the charger system. So if something does go wrong, it's going to switch it to a safe mode, and hopefully not lead to either an electrical hazard or fire or damage to equipment or injury to persons.
Thanks, Bruce. Look, there's another question here with regards to international happenings and how much it's incorporated into the standard itself, or international standards or international developments. The question is, BYD and CATL have recently touted their megawatt charging and batteries as two of the dominant battery manufacturers. Is it known what connectors they use and whether that will come into play in the rail industry?
A little bit too early to tell, I suppose. But the MCS type system, the megawatt charging system, I think is where most people are heading down towards. But it's just going to depend upon the suppliers and where they think it's best positioned for them. I mean, it makes sense for the suppliers to go down the path of a common type of interface for the plug-in type systems. But it's up to each individual organisation, I suppose, to determine where they're going to use it. You might have some parts of the world where they just decide to totally go do their own thing, is what happens sometimes. But in the standard, we have actually, there are detailed cross-reference standards to say that you should comply to this standard, but there's also an Appendix B in the back. We've got a whole dump of additional relevant regulation standards and guidelines for charging information. So there's a whole heap there's Australian standards, there's EN standards, IEC and so forth, and even down to some things, like SAE standards for automotive, which give more information if someone wants to go and look up some additional standards around what can be potentially applicable. We did and ah whether we include that list in, but we decided to. It's not something usual we would put in a RISSB standard, but we thought it would be beneficial to anyone trying to design or integrate battery electric rolling stock, that there are other potential standards and regulations out there that they may want to look at for their entire system rather than just the interface itself.
Is it a fair statement, Bruce, then those were being part of the bibliography at the end, they were incorporated in the discussions in the development of the standard?
They were,
Yep.
yes. Yeah, they were.
Okay, cool.
And it was something that definitely Jacobs, who engaged to this work for us, spent a lot of time researching and developing. So we thought it did make sense to go in there. So, for example, there's even some references here to conductive charging systems for automotive. There's things like the building codes, the Australian design rules. So there are various things in there which are there to assist as well.
Obviously, there's Cris highlighted the charging connectors for the phones and the major issue that has resulted in that. The question asked here is, does the standard cover modularity of design and the ability to adapt to technological advances? Does the standard takes into consideration that to possible future advances and sort of look at that within within the context of the standard itself?
Yeah, at this point in time, it does sort of, for the plug-in type chargers, it does call up the CCS and the CCS2 and the MCS type systems, because that seems to be the predominant way that the industry's moving through the charring group. There's some, if anyone wants to have a look at charring, it's CHRIN. They've done some great work and written some white papers, and we've even referenced some of those in this document. So we pointed towards that at this point in time for the plug-in charging, because that's the best available knowledge that we have. Yes, things may change over time, and there'll be differences and improvements that come out of it. But at this point in time, we've sort of saying, well, you should really use this type because that's what's currently available. We don't know, I suppose, what's going to be available in the future, but as it does improve, as technology changes, and then the standard will need to be updated to look at that.
Quick one, I think the last question, or one before the last question. What requirements would be required to provide the required source power supplies which are suitable for the high demand charging requirements of the locomotive battery?
Yeah, look, we haven't really gone into that specifically because it's one of those things, it depends, right? How many pieces of rolling stock you need to charge at any one time, how much available power do you have? So we have made reference that it is an important consideration. You can't just put these things in and expect you're going to have enough power on your site. So it may involve having to run, more high voltage cables to your site, putting in new substations and so forth to power it. It's the same, I suppose, situation as we get more and more electric cars running around the network, and we stop using fuels, normal petrols and diesels and so forth. Well, you still need to be able to charge those electric vehicles, right? And the whole system, the infrastructure, the power generation, so forth, has got to keep up with that, because we're taking away from one energy source and turning it into another energy source. The energy doesn't go away. You still need to get that energy somehow, and hopefully in a cleaner way, a less carbon emitting way. So yeah, we have talked about it in the standard, but we haven't actually specified it, because it's more about, it's going to depend upon how much you've got. At this point in time, because we're more in a trial phase, I suppose, of this technology, it's probably not as critical. But if you start to move into more production phases, if the technology can be commercialized, then yeah, you're going to have dedicated charging potential facilities with significant amount of power input. And of course, we would want that power input to be clean, right? Clean power, green power. So, well, not necessarily green, but zero emissions power feed. Otherwise, it sort of defeats the purpose. Yeah, that sort of answer that.
Thanks, Bruce. Makes sense. The other question, of course, AI, whether consideration of, we talked a little bit about cybersecurity at a point in time in your presentation, whether AI was considered applied in the battery electric locomotive systems. Whether that addresses, I'm assuming its answer is no at this particular point in time, Bruce?
No, we didn't. Look,
Okay.
AI can be useful in trying to do research, trying to find information out, but as we all know with AI, it's an emerging world, and trying to get the right information, the right inputs that are actually going to give you proper outputs is the trick at the moment, because there's a lot of disinformation out there, and the AI programs have got to learn to work out what's actually useful and what's actually BS. So we didn't really incorporate that at this point in time. As you know, Suda, we've talked about internally at RISSB what AI is, and we're thinking about in RISSB about how AI can assist RISSB and our development groups in developing our standards. It's still under discussion. I know we're working out ways of how we can do that. But yeah, not I suppose in this standard we didn't consider it at this point in time.
All right, I want to give you both the final question. Obviously, the great standard. Are you aware of any earlier adopters of this standard and the progress within their development? Obviously, a lot of people, both manufacturers and rolling stock operators and owners, were part of the discussion in the development. Are you aware of how the early adopters are going and what the progress is at this particular point in time?
I'm not aware. It is brand new. It's only been out, what, a month or two. So I dare say as we go through this year, I'll be in touch with some of the, say the operators, the Pilbara operators, definitely keep in touch with Roger at Horizon to see how they're going. But yeah, at this point in time, I don't know of anyone directly implementing it, but I dare say everyone's who's in this space will be having a serious look at it and trying to see how they can implement it for their particular operation or trial of operations to do this. It may be too early. It might be for a trial operation. You may not need to go down to this extent. But you know, it's certainly part of the future planning and future thinking of how you can apply these types of technologies.
Cris?
Yeah, so like Bruce, I'm not aware of any adopters, but yeah, it is very early days. However, when we presented this at Heavy Haul, there was a lot of interest around the what the standard had to say and how it could be adopted. So I'm very confident that the industry is going to take this up. Obviously, you know, interoperability, harmonisation is really important, and having common types of charging facilities is key to a lot of that around the battery locomotives and battery rolling stock. So like Bruce said, it is very early days, but I certainly see this as being a key driver in the development of these technologies here in Australia.
Thanks, Cris. Appreciate that. That concludes our webinar for today. Just want to thank everyone for your participation and their questions. I hope it has given you a little bit more insight into the standard and what additional information that can provide. If you need additional information, please reach out to info@rissb.com.au and provide some questions, or you can reach out to Cris or Bruce, who can assist you with additional information. I do want to leave with the final word to say the next Tuesday, our next webinar is on the 6th of May 2025. It is the title is Coexistence of Digital Systems. It'll be an interesting presentation of network control about network control systems. So it'll be an interesting webinar. So please, if you've not registered for that, please do so. And I'll see you again on the 6th. Thanks, everyone. Cheers.